Hello again. We're going to start today with the atmosphere, and in a couple of lessons we're going to talk about the composition of air and uses of its gases, pollution of the air and the greenhouse effect and the global warming. And the material is going to be covered in the pages 8 to 12 of the textbook. Today we are going to talk about the composition of the air and nitrogen, oxygen, argon, carbon dioxide gas and their uses. And we're going to talk about the method of separation of gases from the air in the atmosphere, which is the fraction distillation. It's going to cover one period. Clean air is made approximately of nitrogen 78 to 79%, oxygen 20 to 21%, argon 0.9%, and the other gases make 0.1%, from which carbon dioxide makes 0.04%, and water vapor, neon, and other noble gases 0.06%. Now, I gave here for the nitrogen and oxygen two numbers. In the textbook, in today's lesson, you're going to find the numbers 78 and 20. But I have found in a syllabus those two numbers also, 79 and 21. So I wrote both here, and I want you to be aware of that. Let's start with the nitrogen. Nitrogen with a formula N2 makes 78 to 79% of the air. What we breathe is most nitrogen. It is not reactive, no color, odor, or taste. Is present in every living thing in planet. This is so beautiful. The nitrogen is a gas that is a filler in what we breathe. We cannot breathe oxygen. We always say that we breathe oxygen, but we cannot breathe just oxygen. That would kill us. Nitrogen makes the life possible. Nitrogen is a filler in the air, and is used in manufacture of ammonia, and this is used to make nitric acid, fertilizer, nylon, explosives, dyes, and is used in packaging to keep away air from certain products, like in the chips packages. We fill them, they're filled with nitrogen, and nitrogen keeps them from breaking and from going rancid, because we say this non-reactive gas. We cannot fill them with air because air contains oxygen, which is reactive, and the food would oxidize. But nitrogen is non-reactive, so keeps the food from going rancid. And liquid nitrogen is used also in cryogenics, which is the storing of living tissue at very low temperature. Oxygen makes 20 to 21% of the air, has no smell, no color, no taste, and the formula for oxygen is O2. Uses are, the main use of oxygen is the production of steel from cast iron. Is used in oxyacetylene torches. Those are torches used in welding and cutting of metals. And in medicine is used in the treatment of respiratory disease. Is mixed with other gases, and also is mixed with other gases used for respiration in submarines or aircrafts. When we talk about the uses of oxygen, saying is used for breathing is unaccepted and is not accepted in the exams, because we cannot just breathe oxygen. We can say is used with other gases to help in the respiratory disease or helped in breathing, but not used for breathing. Carbon dioxide with the formula CO2 makes up 0.04% of the air and is used in fire extinguishers, in carbonated beverages, is used as solvent for extraction of different organic compounds, and in medicine, like up to 5% is added to pure oxygen to stabilize the oxygen carbon dioxide balance in blood and help provoke breathing, and is used in photosynthesis from the plants. And argon and the other noble gases. Now, What are noble gases first? Noble gases are gases that belong to the group 8 in the periodic table, and they are not reactive. They don't react with other elements. That's why argon can be used to fill the light bulbs because it does not react with tungsten filaments even in the high temperature. And other gases are used in advertising signs. Helium is used in balloons, and being less soluble in water than nitrogen is used mixed with oxygen for divers under high pressure to avoid the bends. And a little later, I'm going to explain what the bends are. So, all these gases are mixed in the air, and to use them, we have to separate them. And chemistry provides us with a method of separations. And the method of separation we used is fractional distillation. And this is based in the fact that gases have different boiling points and goes through some steps. First, air is cooled and compressed, turned in liquid air. And after that, liquid air is warmed up and gases boil one at a time. First, the one with the lowest boiling point, and they are condensed and gathered. I would like you to look up table 1.1 where the boiling points of the gases in the air are given. And this is the apparatus of the fractional distillation. I would like you to look at it and study it because I have seen something like this almost in every exam, and they give the picture without some of these writings here, and you have to know what they are. And let's go together. This is a stand. This is a clamp. And here is another stand for the lamp. This is a distillation flask where we have the liquid air. And this is the fractioning column when the first gas starts boiling and evaporating comes through the fractional column. And this is the condenser. We have cold water going in and warm water coming out, and the gas, when it goes here, gets cooled off and condensed and is gathered in the conical flask. And after the first gas is all gathered, we are not going to have any gas going until the temperature, there's a thermometer here, that's cork, and temperature rises in the boiling point of the other gas, and the other gas is gathered, and that's how they are separate from each other. Now let's go through some vocabulary and some words that we use today. Oxyacetylene torches, we said, is a mixture of acetylene and oxygen used for cutting or welding metals at high temperature. Maybe you have seen that bright light when people weld, workers weld. I would advise not to look at it because it hurts your eyes. And cryogenics is the branch of physics concerned with the production of very low temperatures, temperatures that are used to store living things. And fractional distillation is the method of separating gases, and is distillation to separate volatile chemical substances in which the products are collected as separate fractions, each with a higher boiling point than the previous ones. And the bends is a decompression sickness, dissolved gases coming out of the blood as bubbles. What happens is divers have those tanks in their back and they have air. If they have high percentage of nitrogen, like it is in the air, 78%, they can have a lot of nitrogen in their gas because under the pressure, nitrogen is really soluble. Sorry, in their blood. So under the pressure, nitrogen dissolved and goes in the blood. But when they decompress and come up in the surface, all this nitrogen is going to release as gas from the blood and it's going to get in the joints of the diver, and that creates the bends. To avoid that, we use a mixture of helium because it dissolves less under pressure than the nitrogen. Now I have here some questions, and if you are alone, I would like you to stop the video and try to answer these questions, and if you don't know the answer, go back in the slide and look it up. And if you are in a class, you stop the video and try to answer the questions with each other. And before you watch the next video, I would like you to read from the textbook pages 9 to 11, The Pollution of the Air. Goodbye for now. See you again.